Hello ladies and gentlemen, this is the last section of the semester, which is very exciting. We're talking about using inequalities in a triangle for organization's sake in section 5.5. And to begin this, I want us to look at a triangle and some properties of it, so you can take down this title and pause it. I'm going to move on to a different page. And we're going to look at this. I want you to take a look at this triangle and notice the largest angle and the largest side. And notice their relationship. The largest angle is 87.2 and the longest side is 19.9. They're across from each other. If you choose the smallest angle and the smallest side, they are across from each other. And we know that the medium angle and the medium side then have to be across from each other. And that's true no matter how I adjust and modify. No matter how I adjust and modify my triangle, that fact will always hold true. Smallest and smallest, largest and largest, medium and medium. That, ladies and gentlemen, is a theorem that we are going to talk about. Theorem 510 and 511. These do not have special names because they're not used often in formal proofs, and so we're not going to have special names for them. Theorem 510 says if one side of a triangle is larger than the other, then the angle across from that triangle is larger than the angle across from the other. So in this case, since AB is greater than BC, the angle across from it, angle C, will be greater than the angle across from it, angle A. Converse is also true in 511. If we have one angle that is larger than another angle, then the side across from the first angle will be greater than the side across from the second. A couple of simple theorems, we're going to use them to solve some problems. We'll do one quick example. In this triangle, we're going to list the sides in triangle RST in order from shortest to longest. Well, we don't know the measures of the sides. What we do know is the measures of the angles. So, when we're measuring in order from shortest to longest, well, the shortest side is across from the smallest angle, which is angle R. So the shortest side should be ST. No assumption here. We're using deductive reasoning, using logic, and we're also using theorems that we've talked about because this is associated with the 29 degrees. Our next largest side is across from our next biggest angle. So this is 30 degrees here, so this will be our second largest side, RS. And finally, our largest angle is across from our longest side. So our longest side here is going to be RT, because that's across from our 120 degree angle. So this is our answer here. Pretty straightforward, pretty simple. We are going to now talk about one other theorem we use in triangles in dealing with inequalities and comparisons of things that are greater than or less than. And to do that, I want to first observe another triangle example. Let's say that I have any three sides I want to pick. See if I can form a triangle out of these three line segments. I can adjust positions of sides here, and I'm going to adjust them so they form a triangle. So if I have side lengths 4, 6, and 7, I can form a triangle. But what if I have some side lengths that appear to not form a triangle? So let's take a look at, where is it at? This one here. I have 8, 3, and 3. Well, my 3's aren't going to touch each other because they're too short. So this really can't form a triangle. No matter what position I put them in, they're not going to touch each other. So some segment lengths are not possible to form a triangle. Another example of that is, let's say we have, where is it at? There it is, 3, 5, and 11. Again, they are too short to touch each other. So they cannot form a triangle. There's a theorem where we can tell if three different segments can form a triangle or not. That is called our triangle inequality theorem. Or if you take any two sides, they should add and be larger than the remaining side. So you have three tests to perform. Add two sides together and it should be longer than the other side. So if I add my red and blue side, it should be greater than my green side. If I add my green and blue, it should be greater than red, etc. So we have three tests here. The formal wording of this is the sum of the lengths of any two sides of a triangle is greater than the length of the third side, the side that's remaining afterward. Now, instead of doing 3 tests, I have a shortcut that will work. If you add the small side and the medium side, it should always be greater than your large side. If this one holds true for one of our tests, you automatically know the other 2 will work as well. If we add our 2 smallest sides, they should be greater than the largest. Because then obviously if you add large and medium, it should be greater than small. If you add large and small, it will be greater than medium. So those are common sense because this is bigger than both of these already. So if we just add small and medium and it's greater than large, that's all we really need to do. Our other 2 tests will automatically work. So let's look at that with a couple of examples. Is it possible to construct a triangle with the given side lengths? If not, explain why not. So with our first one, we have a small, medium, and large side. If we add our small and medium side, it should be greater than our large side. Well, if we add these together, it is greater than our largest side, so yes, we do have a triangle here. For the next one, if we have our small, medium, and large, if I add 1 and 4, it should be greater than 6 if these form a triangle. Well, if I add these together, I end up with 5, and 5 is not greater than 6. So no, this will not form a triangle because it fails the triangle inequality theorem. To the small and medium side, when they are added together, the sum is not greater than the largest side. Those are a couple of quick examples. There is another type of problem you may see in conjunction with this idea. This one, a triangle has one side of a length 12 and another of a length 8. Describe the possible lengths of the third side. Well, in the previous problem, we were given all 3 and asked, can it form a triangle? In this one, we know we can form a triangle, and we have 2 sides. We need to find the third one. Well, I'm going to call this third side x. And we have a couple scenarios here. It's possible that x is our smallest side. So it's possible that we have a triangle where 2 sides are 8 and 15. And our third newest side is our smallest one. That's possible. So if that's the case, then x plus 8 should be greater than 15. And if you subtract, I'm sorry, I don't know where I got that 15. That's supposed to be a 12. So if we subtract 8 from both sides, x should be greater than 4. If x is less than 4, it's going to fail our inequality test. It's also possible that x is maybe our largest side in a triangle. Maybe that's x. So that would make 12 and 8 our medium and small. So in that case, 8 plus 12 should be greater than x, our largest side. And if we add these together, x should be greater than 20. Or less than 20, I'm sorry. 20 is greater than x. And I'm going to switch the order of these just to make it look more proper. So I'm going to just kind of flip everything here. X is still less than 20. And so these are my requirements. X has to be greater than 4 and x has to be less than 20. Well, in this case, if you remember from Algebra 1, this is an AND situation because both our arrows are pointing in. So in this case, x is less than 20 and it's also greater than 4. So you can write this as a single inequality. So x is any value in between 4 and 20. You may ask yourself, well, why didn't I do a medium situation? What if x is my medium side? Well, this inequality covers that. A medium side would be something in between 8 and 12, like 9, 10, or 11. Well, 9, 10, and 11 are included down here in this possibility. So all we had to do was find our lowest limit and our upper limit, and x can be anything in between, including anything in the medium range, the small range, or the large range. So this covers everything. A nice shortcut you might have noticed is here I could have just done 12 minus 8 to get 4. Over here I just did 12 plus 8 to get 20. So I don't need to draw these triangles every time. My lower limit can just be subtracting them. My upper limit can just be made by adding them. So let's look at that with another example. A triangle has one side of 11 and one side of 15. Describe the possible lengths of the third side. Well, to find the possibility of my lower limit, I can take 15 minus 11 and I have 4. So in that case, x must be greater than 4. For my large side, I'll add them together. And x should be less than 26. So my final answer is that x is less than 26, but also greater than 4. And there's my range. Again, because this is our lower limit to pass our inequality test, this is our upper limit to pass our inequality test. So that's kind of a shorter way of doing it. As usual, your textbook is a resource. Feel free to ask me questions anytime. This is a brief overview. I hope it is helpful, especially if you're absent. Feel free to email me with any questions.